after we add and subtract like terms, polynomials, we move on to multiplying with exponents. So this is the second day. So how do we multiply polynomials that have exponents? Well, we're going to start off with looking at a couple of examples here. We know that m squared is really equal to m times m. And we know that m cubed is m times m times m. So if we break it down, m squared being m times n, if we do m squared times m cubed, it means we have our m times m, and we are multiplying it times m times m times m. Basically what we do now is we count the number of m's we have. We got 1, 2, 3, 4, 5 m's, so that's our new exponent. Similarly, we have c squared times c to the fourth. If we break it up, we got c times c, and we have c times c times c times c. Just like up above, we count the number of c's. 1, 2, 3, 4, 5, 6 c's. So we end up with c to the sixth. Basically, what we are doing is we are adding the exponents. So if we have the same base being multiplied, we are going to add the exponents. So x to the a times x to the b really ends up being x to the a plus b, whatever it happens to be. So up here it was 2 plus 3 gives me 5. The c's, it was 2 plus 4 gives me 6. So if we have the same base, in this case it was x, we are going to add our exponents together. So a few examples here. I'm not going to do all of them, but I will do a few that we end up seeing commonly. So first problem, x to the fifth times x to the fourth. They're both x's. I do 5 plus 4. It gives me a new exponent of x to the ninth. Number 2, we got 10 cubed times 10 squared. We're multiplying tens, so we have 10 to the fifth, 3 plus 2. Number 3, b to the sixth times b. Again, common view. Here we have no exponent listed, but as long as I have the solid letter here, the b, we have an exponent of 1. So all I have to do is add 6 plus 1. Gives me a new exponent of 7. Number 4, we move it a little bit differently. We have m to the 4a times m to the 3a. Again, as long as the base is the same, we can add our exponents. So m is our base term. So we're dealing with the letter m, and I will add my exponents of 4a plus 3a. So again, they have to be the same term. They're both a's, so I can add the 4 plus 3. Gives me 7 a's. So 7a is our new exponent. Number 5, 6, 7, 8, we start looking at monomials that are involving coefficients. So again, we learned coefficient yesterday was the term in front of a letter. So here we have a coefficient of 2. And for our first parenthesis here, we just have q squared. If I don't see a number out front, I can automatically assume it's 1. So I'll change this to 1q squared times 2q to the fourth. When it comes to this situation, we're going to multiply the items that are alike. So I will multiply number times number and the letter times the letter. So I'll do 1 times 2, 1 times 2 being 2, and then I look at the q squared times q to the fourth. Q being the base, so there's my q, and then I'll add my exponents. 2 plus 4 gives me 6. Number 9 is similar to number 8, only now we have more variables involved. We can only do number times number and then letters times letters that are the same. So here we don't see a number out front. If I don't see a number, again, automatically I can presume it's 1. So 9 times 1 gives me 9. Next, I'll look at the w's. W squared times w to the sixth. W is our base. Add our exponents. 2 plus 6 gives me 8. Then I look at my x's. X to the eighth times x to the fourth. X is our base. And then add our exponents. 8 plus 4 gives me 12. So our answer is 9w to the 8th times x to the 12th. Number 10 is even more involved because now we have 3 variables on top of our coefficients. So again, we can only multiply the stuff that is alike, number times number, and then same letter times same letter. So here we have 14 times negative 3. We can get out our calculator to check it out. So 14 times negative 3 gives me negative 42. And then we look at our f's. F times f to the 4th. Just like up above, if I don't see a number out front, we can say it's 1. If I don't see an exponent on a letter, we can say that it's also 1. So here I have an exponent of 1 plus 4 gives me f to the 5th. Next up, we look at our g. G squared times g squared. G is our base. 2 plus 2 gives me an exponent of 4. And then last but not least, we have h squared times h squared. H being our base. 2 plus 2 gives me 4. So there's our answer. Negative 42 f to the 5th, g to the 4th, h to the 4th. Finding the product means we're multiplying. So 11, 12, and 13, we're multiplying to find the product. So just like up above, we multiply the same item times same item, number times number, letter times letter. Now, finding the power of a power is slightly different notation. So if I take a look up above, when we multiply the same base, notice that they are separate. Finding the power of a power means I am raising something, in this case, x to the a to the c. I'm raising what's inside parentheses to the exponent that is outside. So we're raising a power to another power. What we really end up doing in this case is we're going to multiply our exponents. So in this case, x to the a times c. And again, we do that because it's a different format. Up above, our bases were different. Here we have a base being raised to a different power. So we're going to multiply our exponents. So we have a couple different options. So up above, we learned that m squared is m times n. M times m. So if I think about this, what I'm really doing is whatever's inside the parentheses, I am multiplying, in this case, 3 times. So I am raising each piece. In this case, we have 3. We have x squared, and we have y. So 3 cubed, 3 to the 3rd power, gives me an answer of 27. X squared to the 3rd power, we learned that we multiply, so x is the base, and then we multiply 2 times 3, gives me 6. And then y is our other base, and it's just being raised to the 3rd power. Again, I don't see an exponent, so we can say we have an exponent of 1 here. 1 times 3 gives me an exponent of 3. The other option we have is write down what's inside the parentheses, the number of times the outside exponent is. So we can say 3x squared y, 3x squared y, 3x squared y. And now we can multiply everything that's the same. So this view, this format is similar to what we saw up in the previous section. Multiply similar numbers. 3 times 3 times 3 is 27. X squared times x squared times x squared. Once the bases are separate, we can add our exponents. So x is the base. 2 plus 2 plus 2 gives me 6. And then our other letter y, we have exponents of 1, 1, and 1. So 1 plus 1 plus 1 gives me 3. So we have to be careful of the formatting. Notice up here, we raised each thing to the power, and we ended up multiplying our exponents. Here, we separated it out so that whatever was inside parentheses was multiplied 3 times. Again, once I multiply like bases, I add our exponents. So if we look at the format, power to a power, we multiply. Multiplying like bases, we add our exponents. Personally, I find multiplying to be a little easier. For instance, a to the 4th squared, we can do this a couple different ways. We can do this a to the 4th times a to the 4th, which gives me a, and then 4 plus 4 gives me 8. Or I can just multiply the exponents. A is our base, 4 times 2 gives me 8. Number 2, y to the 6th to the 3rd power. We do the same thing. Because we are raising a power to a power, we multiply the exponent. So y is our base. 6 times 3 gives me 18. Number 3, we start adding coefficients. 2a to the 4th squared. Everything inside parentheses has to be squared. So 2 being our coefficient, if we square that, we get 4. And then a to the 4th, power to a power, we multiply. 4 times 2 gives me 8. And we're going to do the same thing. Everything inside the parentheses, every individual term inside parentheses will have to be raised to whatever exponent is outside. 5x to the 4th cubed, I got 2 different things. I got the 5 and I got the x to the 4th. So each of those has to be raised to the 3rd power. So 5 to the 3rd gives me 125. X is our variable, and we multiply our exponents. 4 times 3 gives me 12. Number 5, here we have 3 different things. We got the negative 6, we got C, and we got the letter D. So 6, the negative 6 has to be raised to the 4th power. Now we have to be careful. If we're using the calculator, if we're dealing with negative numbers and exponents, we have to make sure that the negative number is inside its own set of parentheses. So if I do negative 6 to the 4th, which is the correct way, we get 1,296. Now, if I don't put the negative 6 in parentheses, the calculator reads it as the negative value of 6 to the 4th. So it ends up being negative 1,296. Always be careful. Always make sure that you take precautions. If we're raising negative numbers to an exponent, make sure you put the negative number inside parentheses like that. So the first method, negative 6 in parentheses, gives me a positive 1,296. We have our variable c, and then we multiply 4 times 4. Gives me an exponent of 16. And then we have the variable d, and we multiply our exponents. 6 times 4 gives me 24. We do the same thing with pretty much every other problem on this sheet. I'll do number 10 because it is a little bit different. We got 4/5 a squared cubed, 4/5 being a fraction. Fractions are relatively easy to work with. We just put it in parentheses. So again, 4/5, even though it is a fraction, it's still a number. So we have 2 different numbers. We got 4/5 and we have a squared. So 4/5, a fraction is nothing more than division. So top divided by bottom. So 4 divided by 5, and we are raising that to the 3rd power. It gives me a decimal, 0.512. We could put that as our answer. However, if our problem is in the form of a fraction, our answer should also be in the form of a fraction. So how do we put this decimal back into fraction form? Well, on this calculator, the TI-83 or the TI-84, depending whichever you have, the method is the same. On the left-hand side, underneath the alpha button, it has math. So we're going to hit the math button and we get this nice little menu here. We're going to turn it into a fraction. Notice the very first thing highlighted here is to frac. That is what we are going to use. Basically what is going to happen is our answer, 0.512, is going to be turned back into a fraction. In this case, it's 64 over 125. And then a squared to the third power. A is our base. 2 times 3 gives me 6. So that is how to raise power to a power. Again, be careful of the formatting. Inside to the whatever's inside parentheses can be raised to the third power on the calculator, or we could expand it out and multiply accordingly. Once you expand it out, our exponents are going to be added together. So again, take care of the format in order to be able to put down the correct answer.